Welcome to CW 3.2. Today we're going to be reviewing domain specifically. We'll talk a little bit about range just to put it in context. Recall domain, simply put, is what x can be, and the range is what y can be. So for these kinds of problems, it's more helpful to think about what x cannot be. So for this one, think about how you can plug in anything. So your domain is simply going to be all real numbers because you can plug in anything. Now for b, we have a fraction. And for the fraction, recall that your denominator cannot be 0. So all you got to do is factor this thing, x minus 3, x plus 1. And I can see that x cannot be 3 or negative 1. So I know in Algebra 2 you wrote this as a set. We want to practice interval notation to make sure you can do it. As an interval, it would be negative infinity to negative 1, union, negative 1 to 3, union, 3 to infinity. If you're having trouble with that, just visualize a number line, negative 1 and 3, and imagine you should shade everywhere around these numbers right there. For this next one, we have a radical. Recall if you have a radical of a box, the box must be 0 or greater. So for this one, just write 3x plus 12 is greater than or equal to 0. So 3x is greater than or equal to negative 12. X is greater than or equal to negative 4. And as an interval, that would be negative 4 to infinity. Now to make it more clear, I better highlight these. Now here's our last one. We have a radical in the denominator. So for these, simply take the inside and make it strictly greater than 0. So let's move that over. 14 is greater than 2x. I'm going to switch that for us. X is less than 7. So here is our interval. Okay, so there's our domain. For these, it says apply the following operations. So this is pretty intuitive. To apply operations, you pretty much just follow what it tells you to do. A means add them. So in pre-calc, I hope you can just add them in your head. Let's just add that. That's x squared plus 3x minus 3. Save the domain, so we'll put the domains over here. That's everything. F minus g. For this one, maybe don't do this in your head. It might be better to write it out, just because you got to incorporate the minus for everything. So now we have negative x squared plus x plus 1. And again, your domain here is clearly everything. If there's no fraction, you can just write all real numbers, typically. And for this one, fg, that means you multiply, so we're going to have to multiply 2x minus 1 and x squared plus x minus 2. So just FOIL that. You get 2x cubed plus 2x squared minus 4x minus x squared minus x plus 2. Put that together. 2x cubed plus x squared minus 5x plus 2. Our domain is once again all real numbers. And our last one, part D, f divided by g. So simply just put them one over another. 2x minus 1. And we could leave it factored just to make sure. That'd be x plus 2, x minus 1. You don't have to do that, but it's helpful to have it factored, because now we can see nothing will reduce. And our domain, we can see x can't be negative 2 or 1, so our domain is going to be negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. Now we'll circle that. Okay, so there's our answers there. Now our last example together is right here. These are kind of weird. two radicals and it says add them. So some people want to push those radicals together like we do fractions. Unfortunately, you can't do that. For radicals, you simply just write them next to each other. And there's not a lot else you can do because of the addition symbol. So just put them like that, and you're good. Now B wants the domain of this thing. So do it in parts. The domain of our first piece would be x is greater than or equal to 3. The domain of the second piece is x is greater than or equal to -1. So imagine that you have a number line here. Here's -1, here's 3. For the first piece, it's saying we want everything 3 or bigger. For the second piece, we want everything -1 and bigger. To find the domain of these two things put together, the numbers you plug in have to satisfy both of these, which means we're looking for where these things overlap. So overlap happens right here, which means our domain is going to be 3 to infinity. Okay, that's it.